Hello class, we're going to now talk about transformational form of a logarithmic function. Before we do that though, we want to be thinking about all the functions we've already studied and how that information, transformations in those functions can now relate to logarithmic functions. So let's recall for a bit. Quadratic functions. Here we have in transformational form y equals a, x subtract h all squared plus k. And notice I have color-coded things. A's are all the same here. K, D, D are the same. H, C, C are the same. Okay. Now up here, this was the vertical stretch or vertical compression. This is the horizontal translation and the vertical translation. Okay. Trigonometric functions, for example, the sine function. Y equals a sine b x minus c plus d. Okay, so A, again, same as quadratics, vertical stretch or vertical compression. C, same as this H in quadratics, horizontal translation. D, same as the K in quadratics, vertical translation. Okay, its sine function has an extra little thing here, B, which is unique to that sine function, and in that case, it is the horizontal stretch or compression that changes the period. Changes the period. Okay, so now back down to our exponential functions. Y equals a, b, x subtract c plus d. A is the same A as here. Vertical stretch or compression. C is the same as the C and the H above. Horizontal translation. The D is the same as the D and the K above. Vertical translation. Now, if x is negative, if the exponent is negative, oh, and I also forgot to talk about if a is negative in each of these. If a is negative, we have a reflection in the x-axis. So instead of that quadratic opening up, it's going to open down. Okay, a trig function. If a is negative also, reflection in the x-axis. A also, if it's negative, reflection in the x-axis. Okay, now exponentials has an extra transformation from all of these other ones, and that is if the exponent is negative, then there's a reflection in the y-axis. All right, now remember that for exponential functions, b is not a transformation. B is the base of that function. Okay, so we will only compare exponential functions that have the same b's with each other when we're talking about transformations. Okay, it is true that as b gets bigger, the graphs will increase more quickly. Okay, and don't mix that up with vertical stretch or compression though. Okay. We can also have an A and also a B. There would be a multiplication sign here or a bracket indicating multiplication. Okay, but we will only compare base 2 functions with base 2 functions. Okay, we will only compare base 10 functions with other base 10 functions when we're talking about describing transformations. Okay, all right, so next one, logarithmic functions. And from the previous video, you saw that exponential functions and logarithmic functions are very closely related. They're inverse functions of each other. Later on, we'll figure out how to do that algebra to figure out that inverse function. So transformational form of a logarithmic function. Whoops, still has an A. Still put that in green. And still means the same thing as before, vertical stretch or compression. Excuse me, if A is negative, reflection in the x-axis. Then we have log and the base. Okay, so that's where the base goes. And we have C here. Again. And plus D on the outside again. Okay, notice this plus D is not part of the number that comes after the log. Okay, this is basically all one number, log base B x minus C. And in fact, when you put an A in front of it, that also becomes one number, but then we're adding D to that number. Okay, so these transformations mean the same thing. Vertical stretch or compression. If A is negative, reflection in the x-axis. All right, B is just the base. We're only going to compare logarithmic functions, transformations that have the same base as each other. So we'll only compare log base 10 functions with other log base 10 functions. C, horizontal translation. So moving to the right and the left. And last one, D, it's still the same thing as it was before, a vertical translation. So going to take that most simple base graph and move it up or down. There we have it, transformations of a logarithmic function.